The main thing that we came across from the issues related to supply of water was that the supply of water itself is less. It's around 0.01% of the fresh water, total fresh water that it's available for us. Now let us jump to the water issues related to demand and why we have so much of demand that's causing issues to water resources. So let us just delve into that one. Again, like in supply, again, the main issue that comes with the demand is that the increased population that we have on the planet. And the increase in population is not just by a few thousands, few millions, but it's actually billions of populations getting increased yearly. And because of that, the domestic demand of water is quite high. People use for drinking, bathing, flushing, washing clothes, cooking, and all. So again, interesting thing is that again, developed countries, they have to use less amount of water as compared to the underdeveloped or developing nations. But the case is a little different in case of developed countries. So studies have found out that it's the developed countries that are using around 6 folds or 6 times more than the developing nations. So again, water demand in this domestic side is again an issue. Agriculture, because of increase in population, we have got lots of foods to be produced because of the population increase. The demand of not only the usual normal essentials are being demanded, but also different varieties of agriculture products are being demanded, and that again requires lots of agricultural farming. So we have basically extensive farming going in the different parts of the world, which uses high amount of water again. Even with increase in population, we have got increase in industrial sector again, where lots of goods and products are being demanded. Let's say the increase in population is demanding lots of mobile phones. Even to produce simple mobile phones, directly or indirectly, water is being used, and each good uses a specific amount of water, and that water, if we just add up to all the goods, a huge amount of water comes into play. So that amount used by a specific item or a specific good is basically what water footprint is all about. So water footprint is actually the footprint of water that's being used for production of each item or each good. Or water footprint of a person is the amount of water that's being consumed by that person, either for domestic purpose, agriculture purpose, industrial purpose, or other purposes. So a footprint of any good can be the water that's being used to produce that good. So the water footprint is quite high when we are producing lots of goods with increase in population. And lastly, the power generation again has lots of impacts on the water resources, especially on the demand side. So we are demanding more water because we have to build more power supplies. So when we are building more power supplies, specifically hydropower, electricity, we need lots of reservoirs, we need lots of dam. That's where we're building of lots of reservoir and dam creates a huge surface area for the water to get evaporated from the water surface. So lots of evaporation takes place from the reservoir. So the main concern that we are facing with the water demand challenges in terms of power is that firstly, water that has to be used for other daily purpose like domestic agriculture and industrial purpose is being taken up by the power industry. So a second one is that though they have taken the water for their purpose, they are reserving it where lots of evaporation can take place from this reservoir. So these are basically some things like domestic purpose, agriculture purpose, industrial purpose, and the power purpose. That's making the water to have issues in terms of demand. Experts and water scientists that have forecasted, looking at a few data till 2010, and they found out that actually water withdrawal in all the sectors like agriculture, domestic, industrial, and power, which are using reservoirs, are actually having more withdrawal. So they are withdrawing, or they're using up lots of water resources from the planet. And from sad thing is that the amount of water they have withdrawn is comparatively quite high as compared to the consumption that they are making. So the gap is quite high. So this is the water withdrawal for agriculture sector, and this is just the water being consumed actually in that sector. And the rest, that light blue one, that's being difference, that's the difference between water withdrawal and the consumption, is actually the water that's being wasted, which could have been used for other purposes, for production of other goods and services. In case of domestic, again, the difference is quite higher than the agriculture. Domestic, in case of domestic, like let's say cooking, lots of water is being used for washing dishes, washing vegetables, wasted as grey water, which could have been again used for other purposes. So lots of wastage here, looking at the consumption and withdrawal pattern. Again, in industrial, lots of wastage here. Again in reservoir, lots of wastage. And see, how can we meet this kind of issues if we are to waste so much of water? There is the issue of demand in this kind of sectors where they're demanding more, but they're just consuming lesser than what they have demanded, or what they have actually taken from the sources. Just an example of one of the sectors from the four sector that we just described: domestic, agriculture, industrial, and power. Let's just look at the agriculture. The light yellow ones are where the freshwater withdrawal are from 0 to 16%, and these are the areas where still we have got good amount of water resources. That even includes our country around here. So these are good countries. Again, if you just look at those dark green countries where the withdrawal of water is from 79 to 100, these are countries like India, some Middle East countries, some countries in Southern America. So these are the countries where our water resources is already being scarce now. So they have got more demand, but however, the supply that the water is having is quite less, and they have already exhausted the water supply. One method of withdrawing the water is through pumping the groundwater. And if you just look at the statistics of few 5 to 6 major countries, India tops the nations of the first 5 to 6 countries where the water withdrawal from groundwater pumping is quite high and quite increasing, and it has not stopped now. So it has increased quite drastically from 1960s, and it's not stopping now. A few countries like United States, have actually jumped slightly towards upper side around in 1980s to 1990s, and now they are almost getting stabilized. The graph is going down. Again, that must be because lots of machinery, lots of equipment, new technologies are coming up, which are actually contributing to have a less amount of water in the agriculture sector. So, but rest other countries are increasing slowly, and lots of stresses are to be expected from these countries. Not only for the consumption, domestic purpose, agriculture purpose, power and industrial side, but the water that's being used by these sectors are actually being again uh, wasted. They are not being retreated. They are not being uh, thrown out from their used area as a very clean water that can be used for again other another purpose. So basically, they are making non-renewable, which could have been made renewable. For example, uh, we use water for domestic purposes like bathing, let's say. So to bath, we're using soap and detergents, which are again polluting water, and that water is going to the river system and polluting the whole river system. It's again making the sewage bad, and again these sewage are not being properly treated by treatment plants, because treatment plants are less in numbers, and the sewage that the population is throwing to the treatment plants again in a bad ratio, meaning sewage treatment plants are receiving more amount of sewage and treatment water to be treated through them, again because of mismanagement. Again, if you look at the agriculture sector, lots of fertilizers are being used with water again. So runoff from these fertilizer can actually create quite havoc in water system, which can create eutrophication, and which can again lead to death and pollution of water system. Again, smokes coming out from the cars and industries are again non-treated, and these smokes goes to atmosphere where the reaction takes place with rain. And as you know that acid rain is one of the byproducts of the mixture of the air with the mixture of the pollutants with the water droplets in the air, and the acid rain is again very harmful to those living on the surface. And again, when it goes to the river system, again creates lots of havoc. So lots of stress to water. Again, not only that, but again we see now that water resources like lakes, ponds, tanks are now being converted into landfill areas. If you have visited some of the areas like Pune Sangshu recently, wherever we have got tons where we used to have lots of streams and fresh water coming out of those smaller valleys or smaller gorges, we see that now all these gorges are being filled up with the developmental activities like landfills. So the construction materials, the debris, the soil particles which are taken out from the tunnels, from the digging of dam area, is being filled up in these areas where these waterways like lakes, ponds, streams are being totally blocked, and landfills are coming up. So that's again another issue that's being related to water demand, because if we start to fill these areas with landfill, imagine we do not have a good fresh water supply. What will happen if we just reduce the number of supplies from these areas? Again, lots of countries, like we just saw that India is extracting lots of groundwater from their countries natural resources. Again, it's not only just extraction, but if you do not extract it very properly, extraction could lead to the harming of the quality of the groundwater. Groundwater quality is being affected time and again. Again, like I said, sewage treatment plants are receiving lots of sewage materials, sewage untreated water from the population, from the domestic sites. And again, it's a huge challenge for them to treat. we have less supply of water, and if you do not treat sewage to give water which can be again reused, look at the demand that's look at the gap that cannot be filled because of this kind of lack of facilities. So lack of sewage treatment cannot give good water that can be reused for other purposes. Again, these are again issues. Again, yes, disposal of chemicals and other liquids and waste are again another problem that affects groundwater and aquifers. So mainly we are actually going to face water scarcity. We are not going to increase in terms of water supply and demand, but actually we are going to have lots of scarcity. So by 2025, this red area are the ones which will actually have shortage of physical scarcity of water. So they will feel the physical scarcity of water, meaning they will not be even seeing water to be used for drinking purpose, to be used for some basic needs. So physical water is going to be scarce in this area. If you look at the yellow or light brown areas, these are the areas where water leave the physical water scarcity behind. They will have water shortage even for the economic purposes like building hydropower dams and all. And those area with the light blue are the areas where a little water scarcity is going to take place. And fortunately, again, if you look at Bhutan, we are still in white zone. That means we are quite lucky. Maybe data is deficient in this area, but we are still facing water scarcity problem. You must have gone to other places also, not only in Lobisa, that we have seen water scarcity problem. So data deficit, but yes, we are also going to face serious problem. But in nutshell, this slide is quite important because it really depicts what is the actual water supply and what is the actual water demand and what's left for us to manage. This slide is quite important because this slide shows the water supply and demand scenario of the world by collecting data that was available in 2005 and projecting till 2030. So if you just look at this part is the demand of water, and if you look at the purple part, this part is the supply of water. So the demand of water calculated by water experts and researchers was found to be 4.08 billion cubic meter in 2005, and they projected that in 2030 we will have water demand of around 6906. So the world is going to have around 6906 billion cubic meter of water demand. But let's look at the supply that we have. So already some of the basins are having deficit. That means some of the basins are already drying up due to climate change and other factors. So the drying up is accounted for negative 2765 billion cubic meter. So negative 2765 is already lacking, and somewhere in some of the basins we are finding, and in some ways or other ways like desalinization and other ways, we are generating about plus 81 cubic or like billion cubic meter of water. So we are adding this up. So basically 6906 minus 2765 plus 81, and this gives around 4222 worth of water that we need to supply, like we need in order to meet our demand. So meaning 4222 is the water that has to be supplied in order to meet all this demand. And from this 4222, 688 billion cubic meter of water is again groundwater, which is almost inaccessible to most of the countries. Only 3,534 billion cubic meter water is being accessible as surface water. So to meet all this demand, we still see that we are not able to meet lots of demand. So it's like 6,906 here in, we are able to supply only 4,222. So demand is 6,906 in 2030, and the supply that we can supply from the planet's water resources is around 4,222. That means there is a gap of 40% that needs to be filled. So actually, this is what water supply and demand calculation is all about.